Part 4. How vicon handles animation. Vicon spits out joint centers for all the limb segments, plus the orientation vectors. These vectors are orthogonal like the ijk vectors, except for one thing. They are not unit vectors. If you recall, we use unit vectors so that any coordinates in that system become like vector magnitudes for the ijk vectors. You can imagine if the ijk vectors were of length 2, then any coordinates would be double the size when you transform it. Changing the length of the ijk vectors is really like scaling your animation. Length 1 means no scaling. The object is exactly as it's drawn. Length 2 means double the scale. Moreover, changing the magnitudes of the ijk vectors is changing the scaling along particular axes. So if your ijk vectors were of magnitudes 1, 2, and 3 respectively, then the object wouldn't be scaled along its x-axis, while it would be twice as wide along the y-axis and 3 times as long on the z-axis. For example, you have a forearm with the proximal joint center at 0, 0, 0 and the distal at 0, 0, 1. If vicon calculated that the subject's forearm happened to be 26 centimeters, then it would use ijk vectors of magnitude 26 to scale the animation evenly so that the joint centers are 26 centimeters apart. When you calculate using vicon data, the only thing you have to remember is that you must use the normalized version of all the animated limb segments. That is, one joint center at 0, 0, 0 and the other at 0, 0, 1. And you have to skip the step in the previous chapters where you have to resize the bones. Vicon will resize the bone when you use C-transform with the non-unit vector versions of the ijk vectors. In fact, using C-transform is a combination of rotation and a resize all at once.